So now that we have an understanding of how computers convert or encode information into numbers, let's see how we then further convert those decimal numbers into what's called binary or binary digits, which are bits or zeros and ones. So let's walk through this process. First, I need a binary number. Okay, there we go, for good measure. Now I have a binary number. It's a series of zeros and ones. And to convert this to decimal, I need to write the powers of 2 from right to left over the number, starting with 1. And this is a very common mistake for people who are new to the binary number system, is not starting with the number 1. Another way to think about the binary numbers, or the powers of 2, is you start with 1, and then you just keep doubling as you move right to left. The other mistake that's very common I see in students is that they don't double from right to left, they go from left to right. Remember, the least significant digits are going to be to the right. So 32 and then 64. And now, to figure out what decimal number this is, I add up any power of 2 with a 1 under it. So I'm going to start from left to right this time. Start with 64 and 32, 4 and then 1. So now I get 11 and 10. So this gives me the decimal number 101. Should we try it again with another example? And this time I'm going to write it down and you try it first before you watch my solution. Okay, so give it a minute, see if you can figure out what decimal number that is. So I'm going to start by writing the powers of 2 from right to left over the binary numbers, starting with 1. I think I wrote my number a little bit too close together here. And my previous number had 1, 2, 3, 4, 5, 6, 7 places, as does this one. 1, 2, 3, 4, 5, 6, 7. Okay, and so I'm going to start with 64. I'm going to add 4 and 2. And that gives me 70. Should we try one more? This time try it on your own. Okay. So I'm going to start by writing the powers of 2 from right to left. I start at 1 and I just keep doubling. This time I only go as big as 32. So I'm going to take 32 plus 8 plus 2 plus 1. It gives me 13 and 43. So that gives me a decimal number of 43, and the prior example was a decimal number of 70. So now let's look into converting decimal to binary. Okay, so first off, I'm going to start writing the powers of 2, but I need to know what my number is. So let's take a number. How about 57? So I'm going to start writing down the powers of 2 from right to left. Now, how do I know when to stop writing powers of 2? Well, as soon as I get to a power of 2 that's bigger than the number I'm trying to convert, I can stop. Now I need to figure out what the binary equivalent is. And this process is very similar to how we intuitively make change. If you recall paying with cash, I know people pay with cash less and less every day, but think of paying with cash and trying to make change. If you are going to give someone 84 cents change, you're not going to count out 84 pennies. You're going to count out some quarters because they're the biggest quantities you have to work with. And with binary and decimal, it's very similar, except that we only get one coin for each of these powers of 2, for each binary number. So if I'm going to include a number, I write a 1 under it, and then I subtract it. So first I need to find what's the biggest power of 2 less than 57. That's right, it's 32. So I'm going to put a 1 under there. And then I'm going to subtract it from 57. And now that's 25 is my new number that I'm trying to figure out how do I spell it out in binary. So the next biggest power of 2 that fits inside of 25 is 16. So then I subtract from 16 and I get 9. That's my new power of 2 that I'm working with. 8 fits inside of it. And that leaves me with a 1. So the biggest power of 2 that fits inside a 1 is simply a 1. Any powers of 2 that don't have a 1 under them get a 0. Should we try it one more time? Should we try one more number? See if you can do this one on your own. First, let's try 42 as our next number. I'm going to write down the powers of 2. I happen to know I don't need 64, so I'm going to go ahead and just write 32, 16, 8, 4, 2, and 1. Okay, so let's take a look at this. So the biggest power of 2 that fits inside of 42 is 32. The biggest power of 2 that fits inside 10 is 8. The biggest power of 2 that fits inside of 2 is 2. Anything left gets a 0 under it. So as we can see that 101010 equals 42 and 111001 equals 57.